Hey, Karen, I think I'm here. Shane just joined, and I think we're waiting for Tyler.
Gotcha.
So we're a couple minutes in. I think we can get started. We have Shane, and Tyler is making his way in, but we'll have Shane go first anyways, and while Tyler makes his way. All right. So good morning, good afternoon, good evening, everyone. Welcome to this ICU4X virtual open house event. My name is Ilungo Charan, and I will be the moderator for today. As a reminder, this session is being recorded and will be posted on the Unicode Consortium YouTube channel. So please raise your hand if you'd like to speak during the Q&A. Use the chat box if you have any questions, and keep your camera on if you can, if you'd like. But if you're shy, we understand too. Okay, next slide. Let me introduce you to our virtual open house team. Shane Carr is the chair of the ICU4X subcommittee. Tyler Deniston is a software engineer at Google on the Where team. Karen Dawson is the community engagement and events manager at Unicode. And I'm a contributor to ICU4X and the vice chair of the community engagement team at Unicode. All right, let's get started.
Hello, everyone. I'm going to put my slides up so you all can see my presentation. Hopefully. Let's try it this way. There we go. Okay, hello, everyone. My name's Shane. Thanks, Ilungo, for the introduction. So, oops, these are not the right slides. These are the wrong slides. Let's try this one more time. Those are slides from an event I gave in November about the same subject, but those are not the updated slides. Let me try this one more time. Nope, one more time. Need to have the correct slide open in the correct browser profile. There we go, IC4X virtual open house. You can all see my slides. Excellent. Cool. So across the world, people are coming online with smartphones, smartwatches, and other small, low-resource devices. The technology industry needs an internationalization solution for these environments that scales to dozens of programming languages and thousands of human languages. Enter ICU4X, built from the ground up to be lightweight, portable, and secure. ICU4X learns from decades of experience to bring localized date formatting, number formatting, collation, text segmentation, and more to devices that until now did not have a suitable solution. So first I'm going to walk you a little bit over what is ICU4X. One way to look at ICU4X is via this little phrase here, which I'll break down for you. ICU4X is a modular internationalization library in Rust. So first, what is ICU? ICU stands for the International Components for Unicode. ICU4C and ICU4J are industry standards, which are also maintained by Unicode and Google i8n and others. Internationalization is a class of functionality that includes things such as formatting of dates, times, and numbers, grammatical feature selection like plurals and message formatting, Unicode text processing, including Unicode properties, segmentation, collation, time zones, non-Gregorian calendars, and much more. Modular means that we have small code size as well as low memory usage. We're built around the idea that you should only include what you need. We also are built around the idea that you have pluggable data and dynamic data loading. And this makes it all usable on embedded systems. The 4X part means that we have extensible support via Diplomat, via FFI, which stands for Foreign Functional Interface. It means that we can interface into ICU4X from many different languages, including C, C++, TypeScript, JavaScript, and we're working on Dart, Java, and more. And Rust is a language that's safe by default. One reason we chose it is because we can build blazing fast zero copy deserialization of locale data. And it also is a very good source to be usable from other languages. So overall, the key value proposition of ICU4X is in 3 bullet points, 3 words: lightweight, portable, and secure. Lightweight is the modularity and low code size and memory usage I was talking about earlier. Portable means that you can run it on any environment, any platform. And secure means that it's written in Rust, and therefore we have a lot more guarantees about the code and memory safety and those types of things. So who are we who are working and building ICU4X? You all are familiar with the Unicode consortium if you made it to this call. We're a subcommittee in the Unicode consortium building ICU4X. I work at Google, and we're one of the main contributors to the ICU4X project. Mozilla and Amazon are also big contributors to the project. Okay, so this here is a little demo. I described earlier how ICU4X can run in WebAssembly. What you're seeing here is an example of ICU4X running fully locally in the browser. I can share with you the link to this demo page later. You can also access it from our website. So on the first slide here, I'm doing some number formatting. I type in a number, and you can see the formatted number show up down below, and I can change the locale and the settings. Here's a similar thing for datetime formatting. You can see the formatted output below. I can change the calendar system and the locale. This third one is the segmenter. This is doing word segmentation in some Japanese text. So in terms of project timeline, we started the project in 2020. That was the inception. We did a lot of work throughout 2020 and 2021. Starting in 2022, we had our 1.0 release, which was a major milestone for the team. It's the release that allowed us to start scaling to many new clients because we now have stable APIs that they can use for a lot of important functionality. What we're doing now in 2023 is filling in additional features and onboarding additional clients. And then as we move forward in 2024 and beyond, we're going to continue to focus on getting full feature completeness. Okay, so I'm sure many of you joined this call because you're interested in what's new in 1.1 and 1.2 of IC4X. So I'm going to go ahead and go over some of those items. So I said IC4X 1.0 was released last September, 1.1 was released in January, and now it's April, we have 1.2. So the biggest thing, the thing we've spent a lot of time on as a team is polishing the segmenter components. So the IC4X segmenter or break iterator component is now available and released. We also have spent a lot of time on productionizing properties and algorithms for bidirectional text. We are passing all of the bidirectional text algorithm conformance tests. We also have a lot more support for different bidirectional properties, such as those required by Harfbuzz and other text layout engines. We have a technology preview of the display names component. I want to highlight this one in particular because this is a component that was built not by a core team member, but actually by a contributor who spends just some amount of their time on IC4X and has come up to speed very quickly and is now building major components for IC4X. This is a really great opportunity to get involved. We have a very supportive team. We try our best to make the barrier to entry very low for contributors, and that's how we were able to get this technology preview of the display names component. I mentioned a little bit earlier, we have bindings for Harfbuzz and Skia's SK paragraph. This means that all of the properties and algorithms that are required for text layout in terms of ICU and ICU4X are now available. We also have exemplar characters as well as Unicode set to support strings for those characters. And lots of internal improvements. You'll see a couple slides later how we continue to improve on our baseline that we set in 1.0. So I'm going to show you just a few numbers here for the size and performance of various components of ICU. I'm going to compare it to ICU4C because it's a natural comparison point. So one of the main value propositions of IC4X is that we have small code size, only bring what you use. I spent quite some time in the fall trying to make this particular benchmark comparison as fair as I could. I even went into the ICU4C code and tried some to make it as suitable for dead code elimination as I could. I was able to get a basic number format down to about 700 and change kilobytes of binary size. IC4X is, for comparison, about 30 kilobytes of code size. And the reason for this is because ICU4C is just not built from the ground up for code size, for being optimized for code size. We started IC4X on day one with code size as an explicit goal of the project. This particular bar in IC4C includes a lot of things like locale normalization and chronicalization. It also includes a lot of different parts of number format, including the parts that we're not using in this example, because the code is not written in a way that is suitable for dead code elimination. So if you care about code size, IC4X is definitely a good choice for you. In terms of performance, you can see here, this is a little bit what I talked about earlier. In IC4X 1.2, we've improved on our IC4X 1.0 baseline of performance, which are both faster than IC4C. I also feel qualified, doing these IC4C comparisons because I have also spent time contributing a lot to IC4C, including the number format component. So a lot of this code in the big blue bars is code that I've written. So I feel somewhat qualified to talk about it. So IC4X, because of the way that since it's been written from the ground up to be modular in this way, we're able to get quite compelling numbers out of it. Cool. So segmenter, which is the new component we just released. This slide shows segmenter data size. So We focused a lot when we've been building the segmenter on being able to reduce as much as possible the data size of it. Most of the data size, and I'll talk about this a lot more in a few minutes, much of the data size for segmenter lives in the for how we handle complex scripts like Chinese and Southeast Asian languages. Um, and those are present especially in the word and line segmenter models, which you can see listed here. The grapheme cluster and sentence models, which are the first two columns, I had to multiply by 100 in order to make them visible on this graph. So they're all very small. They're just a few kilobytes a piece. But the word and line models are much heavier, and ICU4X improves on them by about 20% for word and about 60% for line in terms of model size. In terms of performance, we've also been able to realize some gains here. So for word break performance on non-complex scripts, this is English, German, French, and any languages that uses spaces basically. ICU4X was able to be about 50% faster for non-complex scripts and about 30% faster for complex scripts like Chinese, as you can see here. Okay, so now I'm going to take a little bit more of a deep dive into ICU4X segmenter because I know that's what a lot of you are here for. Okay, so I'm going to talk a little bit about how the segmenter works. So there's 4 different types of breakpoints that are supported in the ICU4X segmenter. There's the sentence breakpoints, line breakpoints, word, and grapheme cluster breakpoints. I have these illustrated here in this little hello world example. So the orange bars indicate where in the text sentence, line, and word breaks occur. They all occur on those spots. The green bars are for line and word breaks, and the yellow bars are only for the word breaks. And you can, this is a good illustration of how those different types of breakpoints can occur. You have each of these different types of breakpoints have different use cases, some of which are pretty self-explanatory. Grapheme cluster boundaries are between every user perceived character, so including the characters that have diacritics. Those are all considered one grapheme cluster. But when we get to complex scripts, it gets a little bit more challenging to build a segmenter model. So these examples I'm showing here have no spaces. I inserted these bars in order to illustrate where breakpoints occur. But if I remove these bars, these strings have no spaces or other separators in them. So in terms of this Thai script text on the top, there are 2 word breaks and line breaks in the middle of the text. And in terms of this, in terms of this Japanese text on the bottom, there is a line break, one line break sort of in the middle, or sorry, one word break in the middle, and then a line break for Chinese does not use the complex script models. But in order to figure out how to segment this, we actually need to know something about the languages we're segmenting. So I'm going to go on this next slide and talk about 2 different approaches that we can take toward segmentation of complex scripts. The first general class of models that we can use is dictionary lookup. This means that we can ship a dictionary of words and look up substrings in the dictionary to determine what those breakpoints might be. The other type of approach we can take towards segmentation of complex scripts is the machine learning model. We can train a model such as a LSTM model or a neural network or a transformer on large amounts of labeled data and then infer breakpoints based on probabilities. So these 2 approaches have pros and cons, which are in this little table down here. So the performance bottleneck for dictionary is the data structure lookup. Depending on what data structure you use to store your dictionary words, it could be fast or slow. For machine learning, the bottleneck are the matrix operations because this is a machine learning probabilistic model, and it requires lots of math. So those are going to be the bottlenecks in those 2 types of models. To create the model, what's involved with creating a dictionary? You have to go and source the dictionary from somewhere, decide what words to include. For a machine learning model, when you're creating the model, you have to go and gather large amounts of training data and then train the model. For data size, the data size of dictionary is as large as the dictionary, and So, the more words in the dictionary, the better fidelity you can get. For machine learning, it scales based on accuracy. When we were building the machine learning model for ICU4X, we focused a lot on, well, what's the trade-off between model size and accuracy? And we chose a very good middle ground that gives us very high accuracy while also giving us small data size. Okay, so now I'm going to compare dictionary and LSTM by the numbers. So, there's a bit of a trade-off here, as I described in the previous slide, between performance and code size, and it's good to acknowledge that. So in terms of data size, the LSTMs are much smaller. You can see that the dictionary sizes for these 4 Southeast Asian languages that we currently support are, in the hundreds of kilobytes. When you add them together, they're almost 2 megabytes. The LSTM models are, 100 are less than 100 kilobytes apiece. So, there's clear wins on data size. The catch is when it comes to performance. So on this next slide, you can see the dictionary is quite a bit faster. Lower bar is faster than the LSTM. Also note that this is on a logarithmic scale. So the LSTM is about 2 orders of magnitude less efficient than the dictionary. One of the goals that I've had in mind a lot when trying to optimize the LSTM performance is, can we get to a point where you can take a string of text that you might display on a small screen, like a smartphone or a tablet, and can you segment that in over 60 frames per second, over 120 frames per second? And the LSTM is capable of doing that. That's about where it's at. So if you need to be segmenting, a whole Wikipedia article, the dictionary, is going to give you better performance. But if you're segmenting, small to medium amounts of text, the LSTM is a really good option for you. And so what we've published now in ICU4X 1.2 is ready for you to use. And we're still going to continue to improve on it as we make further releases. One idea that's come up a few times is that we can consider a hybrid approach where we can avoid some of the LSTM bottlenecks by shipping a smaller dictionary and the LSTM side by side. We use the dictionary for the most common words, and we fall back on the LSTM when we encounter words that we don't understand. The hope is that an approach like this would help us, get a lot of the performance back from the LSTM without costing too much on data size. Another big priority, especially for me, I take this one very seriously to myself, is how we can have better support for digitally disadvantaged languages. So currently the dictionary and LSTMs only work on 1 language per script. This is actually a really good reason why machine learning is a really good option here. Because it's very easy for a machine learning model to learn the different characteristics of different languages that use the same writing system. I did a lot of work with Burmese and Zaji a few years ago, and we were able to make machine learning models that supported all of the languages that are written in that writing system. And I'm looking forward to doing the same thing with the segmentation models as well. This third way for improvement is, continue to evaluate other types of machine learning models, including neural networks and transformers, to see if we can get models that are faster on the inference step than the LSTM. So what's ahead for the ICU4X project moving forward? So looking ahead to the next few releases, we're going to be looking at roughly quarterly releases, which means our next release will probably be in the summer. So in ICU4X 1.3, one of the big focuses for the team is going to be lowering the barrier to entry by making data building easier. We've gotten a lot of feedback from users that the approach that we've taken toward ICU4X and particularly locale data has been very much of we give you all the tools to optimize your data. And it requires a little bit of manual steps in order to do that. And I think that was really important for the project, that we gave users that amount of control, but it also raises the barrier to entry. So one of the focuses, in order to get ICU4X to an even broader audience, is to lower that barrier of entry. So that's one of the things we're going to be focusing on this summer. Another thing is we have a lot of experimental and technology preview components, such as the display names components. There's also others, including case mapping, relative time, and compact decimal. So we'd like to polish those components and make those components available for you. In 1.4 in the fall, this is the release I'm really hoping to see date time skeletons and ECMA 402 parity. So right now you can do we support datetime formatting, but we don't support datetime formatting based on skeleton strings. We only support it based on lengths. So for example, you can format a long date in a particular language, and we give you the pattern for that, but we don't support skeleton resolution, which a lot of clients need. So I'm really hoping to see that in the 1.4 release, and also fill in additional features that we need, such as currency, measurement units, and time zones. We already support a lot of these things on a more basic level, but we want to fill in the feature completeness for those. And then our next major release is going to be 2.0, late 2023, early 2024. And in this release, I'm hoping to see an overhauled locale and preferences interface that's one of our team members, ZB, is working on, as well as a more consistent format to parts, which in IC4C is called formatted value or field position iterator. We're going to try to have a more unified approach to that in the 2.0 release. So for everyone who's listening to this call, the IC4X team is small but motivated. We want IC4X to solve more client needs, but we have limited bandwidth to achieve our initial goal of full ECMA 402 coverage. So there are ways that you can get involved to help accelerate the development. One is, and it's very, very helpful to us, is to test IC4X and send feedback and success stories to the team. Contribute new features. We're here to help mentor you on Rust and IE10N, and to share your use case with the IC4X team so that we know what's missing and how we can prioritize work. We're definitely here. One of my favorite things to do when I wake up in the morning is to see a new thread come in from some clients of IC4X who's like, I'm trying to use IC4X to do X, and I can't quite get it to work. Can you help me get it to work? And then I can help them. And that's always a great experience. So I really love when that happens. And that helps you, and it helps us. It helps everyone. So some closing thoughts. The main takeaways from this presentation, again, IC4X is lightweight, portable, and secure. Those three goals that I listed earlier. IC4X 1.2 comes with text layout, including line segmentation. LSTM is small, the dictionary is fast, and please engage with the team so we can better understand your needs. And this is my final slide. For more information, join our low traffic mailing list. Some of you may have learned about this meeting from an email I sent to the list a few days ago. IC4X announced at unicode.org. The way to find out, you can either, this is a Google group, so you should be able to just freely join it. There's also a link to join it from our GitHub page. If you search IC4X on GitHub, you'll be able to find a link to that. If anyone, I'll also post a link in this chat in a few minutes. That's a good idea. In order to give you a link for how to join this this mailing list. You can also run through the IC4X tutorial to learn how to use it. Post questions on the GitHub discussions. If you'd like to start being a contributor, a really good way to do that is to find a good first issue and reply to it if you're interested in starting to work on it. And we have our documentation posted, and you can find that at ic4x.unicode.org. Okay, so that's my section of the presentation. I'll hand it back to Alongo.
All right, thanks, Shane. You gave us a lot to think about. For those of you who have questions, write your questions down and save it for the Q&A. We should move on now to Tyler.
All right, let me go ahead and share my screen here. All right, everyone should be able to see my title slide here. So if that's not true, someone please let me know. All right, well, thank you, and hello everyone. So my name is Tyler. I'm a software engineer here at Google, and I work within the wearables org. And I'm here today to share what's kind of a success story for us in how we used ICU4X to solve our internationalization needs in a wearable device, which is firmly in the embedded domain. So I'm not an internationalization expert, so I'm coming to this group from the perspective of an embedded software developer. So just so you know, that's kind of where I'm coming from. All right, so the device in question that I'm talking about today is the Google Pixel Watch. So this launched just last year in 2022. You can buy it today. I'm wearing my personal one now, and yes, I am biased, but it's pretty nice, so you should check it out. And if you haven't seen it, I have a picture of it on the right-hand side of the slide here. This is a marketing image that I took just from the Google Store page. So this is a smartwatch, and it's in a watch form factor, which is why the kind of primary visual component that you see here is a watch face. So there's the watch hands and the tick marks around the outside displaying the current time. However, there's also some extra information that's being displayed here, and coming from the mechanical watch domain, you actually see this in mechanical watches too, where you have the primary concern being telling the time, but you also have these little extra bits of information, which are generally called complications. And these complications really expand the type and the nature of the data that can be displayed on the user's wrist at any time. So there's a calendar here that you can see that there's weather and looks like some type of world clock. And on the bottom there is an example of one of the fitness metrics that's available, which here is a step counter. So it's saying this user who took the photo has walked about 7,500 steps. So as engineers, when we're thinking of developing software for this device, really one of the most, or if not the most important constraint that we have to keep in mind is battery life. This is probably fairly obvious because as the user, as the wearer of the watch, one of the things you care most about is how long is this battery going to last me? And so this constraint really features prominently in all of our engineering decision making that happens with this device. So one of the ways that the Pixel Watch strives to extend the battery life is through something that we call offloading. So on the watch, it actually ships with two different processors. So there's one kind of normal high-powered processor, and this runs Android. Actually runs Wear OS, which is a specific flavor of Android made for wearable devices, but in the end, it is Android. And this is a fairly typical operating system environment where we have full access to things like ICU4J and HarfBuzz for shaping, different ways to develop applications and display graphics and so on. But within the same physical package, there's also a lower powered microcontroller. And what Android is able to do with this architecture is offload some types of tasks from that high power domain onto the lower power MCU. And again, the primary motivation here is battery life. So some examples of things that might include are sensor monitoring. There are a couple of different machine learning models that are running essentially continuously on the MCU in a low power mode. And then more specifically to this talk, there's also some types of graphics that the MCU is capable of displaying onto the screen instead of using the higher powered processor. So the goal here is to enable the watch to have more functionality that's always on and always visible to the user without sacrificing battery life. So coming back to the context of this talk, the device is intended to be available for a global audience. And what that means is when we're displaying textual data, like some of the data that we saw on the previous slide, we really kind of can't not have proper internationalization support in this offloaded environment. And then kind of crucially, we need this to work in addition to the actual rendering of the graphics and the continuous machine learning models and so on. So the question we faced was, how can we achieve proper internationalization support on this fairly low resource MCU? And I think it should be no surprise, given the context of this talk, that this is where ICU4X comes in for us. So what we were able to do on the Pixel Watch was, before control gets handed off from the main processor to the microcontroller, we take a look at the current locale that the watch is running in, and we ask ICU4J for the locale data, which is it's actually a fairly small little packet of data. And we ship it over a bus to the MCU, where we have ICU4X running. And just for a little bit of concrete numbers here, on the MCU I measured this week, and we were paying about 25 kilobytes of code size for all of our internationalization needs. And this is using ICU4X, which works for us almost seamlessly. So doing this efficiently on the MCU, because it has so little resources, what this does is it leaves more room for other interesting things to also be able to take advantage of the low power domain. So that could mean things like larger or more sophisticated machine learning models, more or different types of sensor data processing, nicer looking graphics, and then kind of as a bottom line, a longer battery life as well. So if you're not used to kind of thinking about what the embedded software development environment looks like, I've highlighted two, what I think are two big categories of challenges that we face, at least with the Pixel Watch. So one, the MCU has very little RAM, which means we don't have the luxury of shipping really large prepackaged blobs of data. And it also means we don't have the luxury of being able to ship really large libraries in terms of code size. All of these resources are being shared by other tasks. And so we need a fairly precise approach for internationalization. On the runtime environment, so it is a microcontroller. There's nothing even close to a JVM available. And then this surprises some people when I mention this, but there's also almost zero use of dynamic or heap memory allocations. So I have a no and an asterisk there because technically there are some uses. It's just every use that we add that pulls in malloc or free or any other type of dynamic memory allocator, we take a very close look at it to see if there are any alternatives. It runs at a very low clock speed, but then the way this impacts your thinking as an engineer is every cycle that you're using to accomplish some computation or task on the MCU consumes battery power, which is directly visible to the user and impacts how they experience the watch. So it's already a challenging environment to develop software for. Adding proper internationalization support is another challenge because it is a completely different and specialized skill set. So I'm an embedded engineer. I am not an internationalization expert. And what ICU4X has done for us is capture that expertise into a really nice kind of tight package of functionality, which helps leave room for other things to work on the watch as well. Then the last note I have here is just from practical experience, integrating ICU4X into the product was actually quite painless. It's designed, like Shane was pointing out, in a very modular fashion. So the sensible architecture means that we really are truly only paying for exactly what we need, which is a great plus for us. And then the bottom line here is that with ICU4X, we're shipping this device, and we're confident that we are able to live up to the expectations that we have for being able to support any locale that the watch is designed to operate in. And I think, yeah, that is my last slide here. So thanks everyone for your attention.
All right, thank you, Tyler. So now it's time for our Q&A. I'll just remind you that we want to make sure that the questions are either about ICU4X or things in the context of ICU4X. And you can use the hand raise feature in the reactions portion of Zoom to indicate that you have a question, or you can type your question in the chat. And I see that we already have a question, which is from Martin. So Martin says, thanks for the presentation, Shane. And you mentioned that you're planning on releasing support for Java, but it wasn't on the roadmap for the upcoming year. When's support for Java planned?
Yeah, thanks for the question. So I'll get you the link for the issue to track Java support. Currently, the status of this is that there's a couple of folks from the Amazon side who are very interested in integrating with Java. So the ball is currently in their court. Obviously this has been a fairly rough couple of quarters for the technology industry, so I don't think a lot of movement has happened on that front. But I think it's definitely we should definitely reach back out and get a more solid timeline for when that Java support is going to be coming. Another option here is that if anyone feels confident in Java, we have a lot of this in order to build bindings from IC4X into Java. We have a tool called Diplomat, where you don't need to be an expert in I18N necessarily. You just need to be able to write code that can take basically an API declaration file and turn it into a Java into a Java API file. So if you feel fairly confident, in Java, this is also a good opportunity for you to get involved. And we have lots of mentors on the team who can also help accelerate this side of the project.
All right, thank you for the question, Martin. Oh, we have another question from Bob. See, so it says, Shane, you talked about performance of the machine learning based segmenter. The example was rendering a page of text, but some use cases might be quote unquote batch, where you have a larger amount of stuff at once, where the performance requirements could be lower. Could ICU4X be an option to the caller to either use this hybrid model for performance or a larger one for better quality?
Yeah, that's a great question. So in the IC4X API, we allow clients of IC4X to choose between either the dictionary or the LSTM model. The LSTM is currently a little bit of additional context here. In order to obtain training data in languages in Khmer and Lao, for example, we use the dictionary in order to sort. We have gathered a very large corpus of basically raw text in Khmer, and then we use the dictionary to segment it, and then we train the LSTM on that. If for Thai, there is actually the Thai Royal Library, I believe, has actually published a very large data set of segmented text in Thai. So a lot of research in this area is basically focused only on Thai because there is this very large data set that is publicly available. But for all the other languages, since we train on the dictionary as the data source, that's sort of the optimal model. It is actually interesting though, because there are cases where the LSTM can actually learn from the dictionary and actually do better than the dictionary. But to answer your question here, IC4X does allow users to choose between the dictionary model or the LSTM model. And this allows that ability to switch between which model is better for that use case. I was also talking with Mark Davis yesterday, and he made the additional suggestion, which I believe we can even ship in a dot release of being able to have dictionary for some languages and LSTM for others within that class. Currently, it's a course switch, and that's definitely something that we can definitely do. if there's clients that need that. I hope that answers your question.
Yeah, and I forgot to mention that you as participants are able to unmute yourself. So if you are willing to unmute and respond, feel free to. Yeah, so Bob, was that good? Okay, Bob says that was answered, thanks. So
Cool.
Alexi, you have the next question. Do you want to unmute and kind of read it aloud for us?
I can totally do that. Thank you. First of all, thank you for the presentation and building this awesome system. So my question is about that there is a lot of emphasis on positioning it as a portable, right? Like with being very conscious about use of resources and being able to make it as portable as and compact as possible, right? I'm curious if you see the evolution of ICU4X for being broader used in like more resource-rich environments. So I think about machine learning systems like that needs to do text processing, right? Where the traditional ICU fits and works well, but like I can also see already some value proposition with a quicker performance and like less resource use already being offered. So I'm curious, are there longer-term plans on actually converging all the ICU libraries into like ICU4X? Thank you.
Yeah, I can take that one. Yeah, so the ICU4X has largely been developed and conceived as a library to solve a problem for a specific set of users. So we're bringing ITNN to these clients and platforms that haven't been able to access ITNN before, and that's been the exclusive focus of the project. Now that we are at a point where we have a actual library and artifact that we can show and use, we've done a lot more of these, like, well, is the future 5 years down the road being that we're maintaining now 3 copies of ICU? Before we were doing 2, C and J. Now we have to also do Rust, which is X, and now we have to do like 3 times the work, right? Or are there ways to converge these? So I'm obviously in favor of like moving forward. Since C and Rust can interoperate very closely with each other. There's a lot of opportunities there for at least IC4C and IC4X to have shared code. And that will be an opportunity to sort of reduce the maintenance burden on our side, as well as give IC4C users some of these benefits for free. Another project that I've been working on when I have time is this a C++ header based library where you can use the same API and you can choose whether you want C or X as your backend, and to allow you to easily switch between C and X if you have a C++ client. Now, clearly, if you're writing, in Rust and your first project, like if you're a Rust project, then there's not really, IC4X is a very, obvious choice if you're writing in IC4X. So this is really only a question of like, if you're writing in C++, which I think a lot of people are doing now and will continue to do for, a very long time, like which is going to be the best library for you. And, we're starting to see, additional clients who are currently on ICU4C and are like, well, now that you've got ICU4X, it has, even though I'm currently using ICU4C, there are some of the benefits, especially things like code size and memory usage that are compelling to me from ICU4X. Can I try this out? So I do see these paths converging, but we're still at the point right now where these are two separate libraries and 2 separate implementations. But I do see paths to converge these moving forward. I have discussed this with Marcus and with the ICU team. So it's we don't have like a 100% agreed upon roadmap, but we have a lot of these ideas floating around, and we're all aligned on what the and the desirable end results would be.
That makes a lot of sense. Thank you, Shen, for answering that. And if there is a way to share for you the library that you've been working on, like on the header for C++, it would be really interesting to look at. Thanks.
Okay, let's see. We have a question from David Rowe previously. And this was related to LDML data. David, do you want to talk about that?
I don't have the text of what I wrote, but basically I'm interested in the ability of being able to dynamically load LDML data specifically for digitally disadvantaged languages, languages that aren't in CLDR but have collected some locale data and would like to be able to just use that locally. A related question is about segmentation. For example, I have a client in working with a So language in Thailand, which uses the Thai script, and the text is being broken according to the Thai dictionary, rather than the actual spaces that are in the in the text. When using the existing ICU libraries. And I'm very interested in the potential for using ICU4X to get the segmentation fixed in that case.
Oh, cool. Yeah. So I'll take. Yeah. There's two questions there, so I'll do those in order. So, first you asked about dynamic data loading for digitally disadvantaged languages. So this here is a tutorial. I'll post a link to this as well. Just basically show examples of how to write some code for that. Basically what's going on here is I've got a directory on my file system. This is just an example. It doesn't have to be on the file system. You can also load dynamically from like from a network. I have hello world data in multiple languages here. And this is just like an example in Rust. You don't need to understand the Rust code. I can certainly walk you through this if you're interested in this, but this is just an example that like it is something that we're capable of handling, where we can basically, like, when we try to load a hello world formatter for a particular language, if it's okay, meaning that it was successful, we're done. We don't need to do anything else. If it was not successful, we can go ahead and load the file from the file system, hook it up into the data provider, and then the next time we try it, it should work. So yeah, this is definitely a use case on day one that was identified that we wanted to be able to support, and that's one of the reasons why we've been working on ICU4X, because it's not as easy to do this in ICU4C or ICU4J. So yeah, absolutely. I definitely see one of the main use cases for ICU4X being like, we ship, some smaller set of locales, in our app, but then in order to support the other, hundreds and hundreds of digitally disadvantaged languages and, smaller locales that are hard to justify shipping in the original app, we can download those when they're needed from like a service and then plug them in to ICU4X. That's absolutely a use case. So let me give you a link to that part of the tutorial. And I hope that answers your first question. Your second question was about can we improve on the behavior for Thai segmentation? And my answer here is I would actually be quite interested in seeing additional sort of test cases for like here's this string of text, here's what a good output would be, here's what a bad output would be, so that we can tune to accomplish that better. I think that there's not really a for a lot of these algorithms that we write, there is like a conformance test suite, like collator, for example, is like a conformance test suite. There's also a conformance suite for rule-based break iterator, but there's not a test suite for like complex scripts like Thai, right? So it would and that's partly by the nature of the language, right? Like there's there's several correct ways to segment a string of Thai text. So like I think one step here would be just to be like, well, if we can identify several use cases or several examples that like we can make sure that work well, that then we can certainly work on optimizing those models. I know that there's a lot of people who are actively working on Segmenter in ICU4X right now, so this would be a really good time to identify those cases and make sure that we behave the correct way.
Okay, I'll try and get that that data to you. Just to be clear, this is not the Thai language. It's another language, but written with the Thai script.
Mm-hmm.
And because ICU, the existing ICU libraries evidently just treat all Thai script as Thai language, they're getting incorrect line breaking.
Yes, absolutely. That's I hear you. It's a big problem. There's also like we don't support Cantonese. We don't support Shan. There's a lot of other languages that use these scripts that we don't support, and that's definitely a priority. And I sort of alluded during the presentation that I think one approach to support these additional languages that are not the most popular language in that script is to actually build a machine learning model, because that'll be able to support these languages without decreasing quality on the main language for that script.
So just a short follow-up. Oftentimes, people in this situation will actually put spaces or narrow spaces or no break spaces, zero width spaces into the text so that it will be broken at the right place. Perhaps the machine learning could actually pick those up and say, aha, these are the places where the words break, and learn from that. But that's something to think about. Thanks very much, Shane. I have to drop for another meeting, and I really appreciate the time that you and your colleagues have put into this.
Thank you for coming, and thank you for the question.
Yeah, thank you. I think we're out of time for Q&A, unless, Shane, you can answer this question real quickly, which is, can we perhaps get a status update on the NPM package?
Yes, yeah, this a quick update there. We do have I believe we have an experimental NPM package that's available, and you can also download the JavaScript bindings in the repository. The WebAssembly demo, uses NPM, or it uses the NPM package. Yeah, it is available. I guess the limiting factor is we haven't had like a person on the team, as well as like a client that we've been working with closely in order to actually publish the NPM package. We have some JavaScript experience on the team, but like most of the clients we've been working with have been like C++ clients, so we've been largely we're a fairly small team. We've been focusing most of our efforts on the C++ bindings, but JavaScript bindings is definitely something I care a lot about. I think it's a really important part of of ICU4X. So we do have those. I would say that they're in a state where I would very strongly encourage you to use them and send feedback on them. And then once we have that feedback, then we can move forward with actually like publishing them further. So this is a spot where your feedback, Derek, would be really, really useful.
And this question is a good segue for us to wrap up. Karen, could you present the final slide? And we'll basically provide a reminder for people on how to get in touch. So if you have any general questions about Unicode, including membership, visit the Unicode homepage, home.unicode.org. And for a question like this about what's the status update of some particular feature of ICU4X or any other kind of question, you can reach the team by opening a new discussion on our GitHub page, which is github.com, unicode-org, ICU4X. Or you can file an issue too. And if you open a discussion, we can convert back and forth. As a reminder, a recorded version of this event will be posted on the Unicode YouTube channel. And thank you all for attending. Have a great day. Oh, sorry, I'd like to also just give a quick thanks to everybody. Shane and Tyler for presenting and answering questions. Karen for all the logistics, for during today and all the lead up to today. And to our other volunteers and contributors in ICU4X. And thanks to all of you for attending. Yep, so have a good day, everyone.